All right, Mr. Trutna here. Hold on 1 second. I'm walking around the classroom. All right, sorry about that. Clovis High School, we're going to go over Unit 9, Worksheet 1. We're in Math 2. Make sure after this video to smash that like button. Okay, so tradition says we got to start it off with a joke. You got to watch the whole video to get to the punchline of the joke. So, what do you call a bear with no teeth? Well, you're going to have to watch the video to find out the punchline to the joke there. Okay, so here's Worksheet 1. These numbers, I don't know if you can see this at home. Yeah, you can. So the ones highlighted are the ones that we're going to be working on. And I'm not going to do every, whoops, sorry, that's Worksheet 2, I lie. This is Worksheet 1 right here. The ones highlighted are the ones we're going to be working on. I'm not going to do every problem. I'm just going to start with number 7, and I'm going to skip every other one. So we're simplifying each expression. Okay, number 7, we got 5x plus 5x. So remember, when we are adding or subtracting, we have to have like terms. These two terms are like, so you only add or subtract a coefficient. So 5 plus 5 is 10. You leave the variable as it is, and if there were any exponents, you wouldn't change them. Number 7 is 10x. Okay, moving on to number 10. The same philosophy applies for subtraction as it does for addition. You have to have like terms. Notice, since both of these terms have an x in them, and since both of the x's have an exponent of 3, these are considered like terms. So what we do is we're going to subtract the coefficients. We're going to take the 4. We're going to subtract 12 from it. 4 minus 12 is negative 8. We leave the variable, we leave the exponent, so number 10 would simplify to negative 8x to the third. Okay, we're going to skip number 11, we're going to move on to number 13. Number 13, as you can see, is an addition problem, then it's a subtraction problem, and it's also an addition problem. And there are parentheses involved. Okay, so your best bet when you're working with parentheses is first of all, rewrite the problem so that there are no parentheses involved at all. The first parentheses, you could literally just drop the parentheses, but the second set of parentheses here, this negative sign causes everything inside of it to become the opposite of what it is. So since this is a positive 2x, it makes that a negative 2x. And since this is a plus 9y, it makes that a minus 2y. Okay? So then when I add or when I subtract, once again, you can only add or subtract like terms. So I'm going to start right here with the 10x. What's a like term with the 10x? Well, it's a minus 2x. 10x minus 2x gives me positive 8x, and I could just write 8x. I don't have to put a plus symbol there. And then I'm going to take the positive 3y, and I'm going to combine it with the minus 9y. Those are like terms, so 3 minus 9 is negative 6, so I would get negative 6y, and that's your simplified expression for number 13, 8x minus 6y, okay? So what was the key to this problem? Write the problem without parentheses. If you have a negative symbol in between the parentheses, a subtraction symbol, make sure to distribute that subtraction or negative symbol. We're going to do the same thing with number 17. So we have parentheses, then we are subtracting another parentheses. Let's rewrite the problem without parentheses. So I get negative r to the third plus 2r minus 1. Notice the first parentheses doesn't change at all, but then the second parentheses, this minus symbol right here, when I distribute it, it's going to make all the terms opposite. So the negative 5r squared is going to become positive 5r squared. The plus r is going to become minus r. The plus 8 is going to become minus 8. Okay, so now when I add or when I subtract, or when I add or when I subtract, or when I subtract, I can only add or subtract like terms. So I have a negative 9r to the third. So I'm looking for another r to the third. and you could see I don't have any other r to the thirds, so there's nothing to combine with negative 9r to the third, so that's just going to be part of my answer. Okay, and then what you should do is you should work through the problem in descending exponential order. So the next part that I'm going to look at is the positive 5r to the second. Okay, I'm looking for any other r to the seconds, and you can see there are no more r to the seconds, so that means I'm going to have a positive 5r to the second in my answer as well. And I cannot combine these two together because even though they both have an r, the exponents have to be the same in order for them to make them like terms, and you can only add or subtract like terms. Now I'm going to work with my r's, so you can see I have a positive 2r right here. And then I have a minus r right here, and that's like a minus 1r, and I'll write in the 1, you don't have to do that. So I can combine these. Positive 2 minus 1 is positive 1, so I'm going to get a positive 1r, and you don't have to write the 1 as the coefficient, you just write plus r. Okay, and then lastly, I'm going to combine the numerals together. The negative 1 minus 8 gives me negative 9. So there's your simplified expression for number 17. Okay, moving on to my next problem. The next problem I assigned to you was number 28. I'm going to skip that, and then we're going to go to number 29. All right, so this says compare polynomial and radical expressions. So here we have our polynomial expressions, and we're going to simplify it. So 3x plus 5x is equal to 8x. Then I'm going to go over here and I'm going to add 3 radical 2 plus 5 radical 2 would be 8 radical 2. Okay? So notice when I'm adding polynomial expressions, I'm adding the coefficient, and I'm leaving the variable x as it is. When I do radicals, I add the number in front, the coefficient, and I leave the radical number 2. I don't add that. Okay, 3x plus 5y, those are not like terms, so 3x plus 5y would be equal to 3x plus 5y. 3 radical 7 plus 5 radical 2, because those inside radicand numbers are not the same, they're not like terms, so 3 radical 7 plus 5 radical 2 is equal to 3 radical 7 plus 5 radical 2. Okay, now we go to part C, multiplying. So multiplying is a different rule. So remember, both of those x's have an exponent of 1. 3 times 5 is 15. And then we get x to the power of 2. So remember, when you multiply, the rule with exponents is you multiply the coefficients and you add the exponents up. That's where the 2 came from. Now when I multiply radicals, I do it the same, kind of the same idea. I'm going to multiply the two outside numbers together. 3 times 5 is 15. Then I get a square root of, and then I multiply the inside numbers. 7 times 7 is 49. So that would become 15 square root of 49. And if you wanted to simplify this, this would mean 15 times 7. And if you multiplied that out, that would be 105. Okay? All right. 3x times 5y. Now you can multiply even if the variables are different. So 3 times 5 is 15, and then you would get xy. Okay, so you don't need like terms to multiply. Same here, you don't need like radicand numbers to multiply. So 3 radical 7 times 5 radical 2, you would take the 3, you would multiply it by the 5, that is 15, then you get the square root, and then you would take the 7 and multiply it by the 2, so we would get 15 and radical 14. Okay, so part B, how are the rules for adding polynomial expressions? So we're talking about, in part B, we're talking about how do these rules for addition, okay, how are they similar to the rules for adding radical expressions? Okay, so they're very similar in 2 respects. The first thing is you can only add like terms. In both cases, they had to be like. And then the second part that's the same is you only add the coefficient. So you only add the coefficient. Coefficients, I guess, would be the correct way to put it. Okay? In part C, How are the rules for multiplying polynomial expressions similar to those for multiplying radical expressions? So you can see right here, how are these rules similar for these rules? And I would say the rules are you don't need like terms, okay? Don't have to have like terms to multiply, have to have like terms. That's the first thing. And then the second part that you maybe would have noticed that makes these two rules the same is you always multiply the coefficients together, and then you always then multiply the variables or the radicals together. Okay, so you multiply the coefficients. Okay, both of these have coefficients, and you multiply the variables or radicals. Okay, there you go. So there's half of your problems right there. Hopefully that helps you out, and that could get you going if you're stuck a little bit. All right, so here we go. The answer to the joke of the day: what do you call a bear with no teeth? A gummy bear.